Wow. Let's try another one. There we go. There we go. Yo, it's Aiken! How we doing, bro? How are we doing? Let's turn this down. Yep. Probably a bit better. Little loud for you. Aiken, my dude, how you been, my man? I hope things have been cool for you, buddy. Been a while. I haven't heard from you in a little bit, man. What you been up to? Let's turn this on. Yeah, let's do that. Let's do things. Good job, me. I know what I'm doing. I'm competent somehow. I'm not really that competent, Aiken. Aiken, man, what you been doing, bro? Oh boy. All right. There we go. Man, it's been a little bit. I hope you're doing good. Hopefully today's been pretty chill. Hopefully everybody who's in here has been doing pretty good here this fine day. This fine day. This very fine day. Hopefully you've been able to have a great time doing whatever it is that you need to do. Hisa, good evening to you. Good evening. How are you? How we doing today, Hisa? We got plan Pistache. Hello, hello to you. How are you? That's okay. Look, I understand if you need to shout it in my face. It's fine. Digitally or figuratively or literally. All are okay. I'm good. I'm doing good too. I'm doing fantastic today. I hope you guys got plans for this weekend. You got plans for this weekend, you know? We got plans for this weekend, and let's do this stuff, you know? We got some fun things planned, you know? Ho ho ho. You know, I'm looking at myself and be like, you know, the beard is getting a bit thick again. Maybe it's another time to start getting rid of the beard once again. You know, been a couple weeks or so. That wouldn't be such a bad idea. I don't know. I don't know. Maybe that would not be so bad. Alright, we'll go with this. There we go. I don't know for sure. Maybe hang out with friends for the first time in a long while. You know, that's kind of true. You know, the longer you don't hang out with friends as much as you used to, you know, with especially the COVID around, it's tough. It's tough to go outside and hang with friends and, you know, do stuff. It's a little bit difficult, you know, I ain't gonna lie. You know, like, life gets in the way, I gotta do homework, I gotta do stuff at home. You know, all that stuff kind of gets in the way, and then suddenly you have less time to go hang out with peeps. But hopefully you'll get a nice chance to just hang out and just chill and just to have a nice time. I think that's all good. Alright, we're going to get started here in just a couple of minutes, and then we'll get going here with the section of the day. And we'll rip through it like hot knife through butter, and we'll be okay. Chioma, good evening to you. Good evening. Good evening to you, Chioma. I hope you are doing absolutely fantastically well. We're still on a good pace of finishing on time, so we got lots of time, actually. Now that I look at it, man, that is more time than I thought. That's true. Plus, I haven't really done anything for myself of late. That's true. That's true. You know, we need to take a... I think everybody needs to take a step back and do something for themselves. And focus on just their self. And I think it's good for you and your mental health. I think for mental health, it's really helpful. Just change of pace. That will be a positive thing toward you. So I like to do that every once in a while. So just a positive, just a change of pace that'll help me, you know, put myself in a better state of mind. It's been a busy week. I'm going to be busier weekend, but it's all good. That's good. That's good. You know, maybe busy, but, you know, don't try and overwork yourself there, Chioma. You know, keep it nice and easy. Hopefully you'll get through this weekend no problem. Anytime you have a test, try not to make the task bigger than it needs to be. So I always think of it that way. Make a task too big, suddenly the task is much harder and busier than you thought it was. Alright. Alright, ladies and gentlemen. Okay, ladies and gentlemen, we are going to go ahead and get started here right now with some new stuff here. Alright, I hope you are going to be ready, because I'm ready. Let's go. Let's do this. Okay, let's get started with today. Welcome back to Thursday. Alright, end of the week time today. So today, everybody, we are moving into... We finished up last time, just finishing up talking about hypothesis testing. Today, we are going to be going from Chapter 10 to Chapter 4, okay? Chapter 4 is the very, and yes, I do mean the last chapter of the textbook, alright? So we are in absolutely fantastic shape here, okay? We are in the last throes of the textbook. If you're excited, I hope, maybe, I don't know. Let me switch this up here. I don't know if you're excited, but I'm excited that we're getting into the very last days of doing this stuff. All right. But we have some things we certainly have to talk about, and certainly do. All right. So we've looked at a lot of different things here throughout the course of the semester. All right. And one of the things why Chapter 4 is kind of like here at the end is because it kind of compiles a lot of the things that we've done here, and kind of says, all right, we can put certain things together here. Not maybe hypothesis testing and whatnot, but looking at certain data, looking at data sets, looking at it from the big picture perspective here, puts a nice little bow on pretty much a lot of the things we've kind of compiled and put together a little bit. I wouldn't say a total summary, though. In any case, you know what? Enough talking, more doing. All right, got a big board here. Okay. So let's take a good look here at things we have seen before a little bit, but we'll acknowledge now. All right, so today we're going to be talking about scatter plots. We're also talking about how to correlate two things together. If one of the things that is going to be realistic, it's how we can basically see if there's a relationship between two things in any given study or whatever the case may be. We want to be able to look at something like that. We're just going to look at that from a very basic perspective here in this chapter. All right, so let's take a look at question 1 here. What is a scatter plot? All right, a scatter plot is a graph that shows the relationship between two quantitative variables measured on the same individual. So for example here, what we call x and y, you guys have probably seen a scatter plot before, but just on the level here. Here again, as you know, for any graph, here is x, here is y. Okay, so x is the explanatory variable, so it's like, okay, will help explain something, and y is the response to that explanatory variable. Again, just like if we input a number for x, we get a number back out for y, whatever the case may be. So, two things that you can relate, for example, caloric intake and BMI, which is body mass index. Okay, so maybe you have a higher caloric intake, you have a higher BMI. Okay, so something like that could be, for example, could be something like that. Could be caffeine taken, number of cups of coffee versus energy, or, however you can measure that out. There's a lot of different relationships you can try and test out. Anyway, what we will see on a scatter plot will be like points on a graph. It could be points that kind of look like this. So each of these black dots here could be random points from our data set that would reflect, hey, this is what the general relationship between x and y look like, taking different people and monitoring their results, and there you go. So you say you have 2,000 caloric intake, okay, you have a BMI of, 25 or whatever. It'd be something like that. Okay, so that's a scatter plot in general. Now, let's go to question 2 here, as, yes, this is blank here on the screen, because I think it's, we're going to come back to this here, what can a scatter plot show in terms of a relation between two things. I want to go ahead and showcase this off here along with another question. So I'm going to skip this question for right now, and then we'll come back to this in just a moment. Okay, so in order to basically showcase this to you guys, I need to at least demonstrate the numbers behind that. So we'll talk about that here in just a moment. Now, we're going to talk about a very important concept here. Okay, we're going to talk about a very, very important concept here, which is called the linear correlation coefficient. In this case, the sample linear correlation coefficient. Okay, so it says here, how do we find the sample linear correlation coefficient? All right, and here is the formula about how to find the sample linear correlation coefficient. Now, I do want to make one note in regards to this particular formula. Let's, before you start writing this down, please stop writing this down, okay? So, one thing I want to make note of is the notation for correlation coefficient. For correlation coefficient, we have the notation here of R, okay? R is the correlation coefficient for this particular process. Now, this R here, this value for R, we're going to find out is exactly going to determine what kind of actual linear relationship we have between X and Y, and how strong that relationship actually is. Now, if you take a look at this formula here, this looks pretty ugly. You got this xi minus x bar, and you have this sx, and you have yi minus y bar, and sy and n. Again, I put the definitions for each of them here. Xi being the data items, yi being the data items for the y's, x bar being the mean for the x's, y bar being the mean for the y's. You have the standard deviation for the x's and the standard deviations for the y's. Now, I'm not going to make you memorize this, okay? I'm not even going to have you do anything with this in the calculator, okay? So I've written this down as just like, again, as a supplementary thing. Should you want to see it or have it in your notes, you can go ahead and write this down. But there is no way the process here, if you do it by hand, would take quite a long time. especially given the fact that you have to add all those up together. You have to take all the data items in the data set, add them all up together using this formula. It's pretty ugly. It's pretty ugly. So we're going to forego that doing all together, and we're going to actually see how we can do that here via the calculator in a different way. Okay, so obviously I don't want you to write this down unless you just want to have it in your notes for completion's sake. Okay, now for us to understand exactly how this linear correlation coefficient is going to work, though, this R here, and how we can basically put two things together here. Let's talk about number 4. Now, number 4 is very important because this will help us kind of guide ourselves into talking and breaking it down a little bit further. So what are some properties of a linear correlation coefficient? Number 1, R here is between two values, -1 and 1, including -1 and 1. So we're going to get any number here between -1 and 1 here for this linear correlation coefficient R. Now, what does it mean at the end of the day? A negative R here indicates a negative linear relationship, and a positive R indicates a positive linear relationship, okay? So negative number, negative linear relationship, positive R, a positive linear relationship, okay? Now, there is one more thing here that we do need to talk about here, so let's talk about this in number 5. There's one more property here. How can we interpret the linear correlation coefficient? Well, one more property here that we can also include is this. The closer R is to 1 or -1, so the closer it is to 1 or the closer it is to -1, the stronger the relationship is between both variables. So we can make a claim that a relationship between x and y is stronger if it's closer to 1 or it's closer to -1. Okay? That's the claim that we can make here. So, how does that help us here, and how does it help us visualize what will actually be happening here between two things of x and y? Let's talk about what we have here down here, and then it'll start making sense. So, what we have here is we have some tiers, like we have basically a tiered system of talking about how strong the relationship is between x and y, depending on what we get for R in the particular calculation. We're going to look at an example about how to solve for R here. So I know that I'm being a little abstract right now, but we will see something more concrete after we're done with this part. So if R is equal to 1, we call it a perfect positive. We have a strong positive. We have a weak to moderate. We have no relationship, weak to moderate, negative. We have a strong negative and a perfect negative. Now, the way to kind of put this out here is I want to basically help ourselves out to understand each of these particular tiers. That's why I made question 2 here. What can a scatter plot show in terms of a linear relation between two things? Let's take a look at each. Oops, I went too far. Let's take a look at each one of the meanings here, and let's look at it from a picture perspective using a scatter plot. So let's go with R is equal to 1. Now, as we know here from the left-hand side, that's a perfect positive linear correlation coefficient. So what would that look like if I were to look at it as a scatter plot? It would look something like this. Okay, so it looks something like this. You could literally take a line, and you could draw right through every single one of those points, and you could make it'd be perfectly level, as terms of a line. So, there you go. That would be perfectly fine. That line would go through every point, and that's perfectly cool. So this is a perfect positive linear correlation. Alright, let's look at the next one here, which is going to be, okay, so again, this is perfect positive. Alright, next one here is going to be R is between -0.9, not negative positive 0.9 and 1. So what would that look like here? A strong positive, again, it would look something like this. And it's not perfectly in a line, but it's pretty bunched together, it's not exact, but it's pretty close, so you can kind of make it this way. So this would be like a strong positive here. Strong positive, very good indicator. Okay. Let's look at the next one. All right, weak to moderate. So let's say R here is less than 0.9, but a touch above, just bigger than or equal to 0.4. So in this instance here, this would be, again, a little bit more spread out. So again, it maybe not as close, but still holds a generic pattern that's pretty good. Okay. So something akin to this would be a perfectly fine, you know, weak to moderate sort of thing. Boy, that K looks pretty awful. There we go. Pretty bad. K, the letter K. Alright. Alright. Alright, let's look at the next one here. What if we have no relationship? If there's no relationship between X and Y, right? Let's say there's no relationship here. Let's say there's no relationship here. If there's no relationship here between X and Y, then this is effectively what it looks like. You just have pretty much, they're all over the place. There's no rhyme, there's no reason, there's no pattern behind any one of the points here on the scatter plot. It is what it is. It's just everywhere. It's like, okay, cool. Alright. It is what it is. So it's like, alright, whatever. Alright, next is going to be, again, no relationship here, by the way. Oops, forgot to put that down. It'll be between 0.4 and negative 0.4. So let's just not forget about that. E. Alright, next is between negative 0.4 and negative 0.9. Again, not including negative 0.9. So this is a weak to moderate negative linear correlation coefficient. Just flip this on its head, just like you would weak to moderate positive. Okay. So of course, a negative correlation is going to be just going down, just like just kind of like that. So weak to moderate. Negative. All right, and then the other two here, pretty simple. Next, we'll talk about a strong negative. So again, that's between negative 0.9 and 1. So we have this, a little bit tighter, but not exactly perfect kind of data set. There we go. And then finally, the last one here, R is equal to negative 1. So we're going to get to here, again, a perfect negative. Again, perfect negative is exactly what it sounds like. You're just going to go make a dotted line. There we go. All right. Okay, so this is basically describing how scatter plots can basically talk about the relationship between two things in terms of a linear correlation coefficient. There are other relationships as well. It's not always linear. You can have a non-linear relationship as well. Although the only things that we're talking about is a linear relationship. So a non-linear relationship would be something like a parabola or something else in the shape of a parabola. A non-linear relationship would look something like this. Like if you had something like this, or again, if you had something like this. Like, I don't know, like this. There you go. These are non-linear in nature, so you get the idea. They're not lines. All right. Okay. Any questions about these first 5 questions? Any questions at all? I know it's a lot of information. But any questions? No? Alright. Alright, so make sure you know what kind of relationship that we have. We're gonna figure that out here. Now, let's talk about how we can go ahead and do this out. Alright, let's look at question 6 here, as we are going to talk about now actually looking at ways we can figure out if there's a linear relation between two variables. So, let's look at number 6. How can we determine if a linear relation exists between two variables using the linear correlation coefficient? Alrighty. Alright, so we are definitely going to use the calculator here. And again, it does depend on new school, old school sort of thing, but we're gonna see exactly how this works, okay? So, alright. Now, I'm gonna need the textbook here for just a moment. We're gonna use an example here. Alright, but I'll need to write down the values here that I would like. So let's go with this one here, number 17. Alright, so we're going to go with number 17 here. I'm going to write this down. We have x and y here respectively. So we have 2, 4, 6, 6, and 7. And we have 4, 8, 10, 13, 20. Alrighty. Alright, now I'm done with the book here for this one. Okay. First and foremost here, ladies and gentlemen, I would like you to take out your calculator. Alright? So please take out your calculator. Make sure that's in front of you for this. It is button presses time. Alright. Once you have your calculator out, please type in "got it" in the chat so I know that you are on board with starting. Please type "got it" in the chat once you have your calculator out in front of you. Okay. Everybody okay? Tori's got it good. Alright. Anybody else? Everybody good? Stash, we good? Stash, Clay? We got our calculators out? Okay, got it. Okay, good. Alright. Not sure where Pistache went, but maybe took a step away. Alright. Alright, so let's take a good look here at the calculator. Alright, first and foremost here, what we're gonna do is we're gonna enter in our couple of lists here. First and foremost. So let's go ahead and hit the stat key here. And we're gonna go to edit. Alright. Now, if you have stuff in your lists here, like I do, then you want to go ahead and clear out these lists here. So to clear out these lists, we're going to go ahead and highlight the list, hit the clear key, hit the enter key. That will make sure we clear out the list. So highlight the list, hit clear, and hit enter. Highlight the list, hit clear, and hit enter. Alright, so all your lists should be empty here. Now for list 1, we're going to go ahead and type in everything in for X into list 1. So 2, 4, 6, 6, and 7. And then list number 2 will be 4, 8, 10, 13, 20. Alright. Alright, when everybody has that entered into their calculator, please type in yes in the chat, and we will just making sure everybody's got all their stuff in their calculator, and we'll move forward. Please type yes in the chat once you have all your stuff entered in. Okay. Wait on Shioma. Shioma, we have our stuff entered in there. Okay, perfect. All right. Hope everybody's with me here. Okay, now, the next part here, I'm going to be honest with you, will be a little confusing, okay? Now, I'm going to point this out here first. You only need to do this one time, okay? Okay, so let me put this in the chat here. You only need to do the next process one time, unless you change batteries or hard reset the calculator. And what I mean by hard reset, that doesn't mean turning it off and on. If you have to like clear all RAM or something like that. So it means again. Okay. All right, so I put that in the chat here. So what we're going to do here first is we're going to go ahead and hit the second key and the mode key. Okay, so we'll get back to the main screen here. Now, one of the things, there is a particular reason why we're going to do this next part here, is that the calculator by default does not show you what the correlation coefficient is. For whatever reason, the default way that the calculator will tell you is that they will automatically leave off the correlation coefficient, which is what we're trying to find here in this problem. We're trying to find what R is, but it's not going to tell us right away because the calculator has that off for some reason. So we need to turn that actual thing on in order for us to actually see that number and be able to use it. Now, in order for us to do that here, what I would like you to do first is hit the second key. So please hit the second key and hit the 0 key. Just hit the second key and the 0 key. And you should get to this menu here. The second key and the 0 key, you should get to the catalog here that you see here on the screen. Then, what I would like you to do is, there's not really a nice way of doing it, so you kind of have to keep scrolling. So we're going to scroll all the way down to letter D, and we want to go to, I'll put this in the chat here first. I'm going to go to diagnostic on, okay? So I want you to go to this menu item here, which says diagnostic on. And there it is. It says diagnostic on, all right? And then hit enter twice. And then this is what you should see here on your screen. So I hit enter on that, and then I hit enter again. And it should say done. All right, so please type done in the chat if you have gotten this finished. Okay, make sure everybody has to do this, okay? So this is not really an option. You have to do this. Otherwise, you will not be able to find the answer to this question. So, you just have to do it this one time, though, and then we don't have to come back and do it again. I want to be sure everybody's got it. Hisa, did we get it? He says, got it. Okay, good. Okay, Gally, Tori, Anna, Shioma, Pistache, Clay, Jake, and Chimpin. We're all good. Let's see. Anybody else? Anybody else? Juan. I think Juan is the only one that's left. So let's see if, I guess we'll... Alright. Well, we'll have Juan come... I'll have Juan come back and we'll have him do that, so that's fine. Alright. Okay. So, let's talk about what we want to do next as we're going to move forward here. Alright. So what we're going to do next here, alright, is we're going to go ahead and we're going to go ahead and hit the stat key here. Alright. So we're going to hit the stat key here and scroll over to calc. Okay. Just put this in the chat here. We're going to hit stat and calc, and we're going to go to the special. We're going to go to number 4. Number 4 that says linreg AX plus B. Okay. Let's put that down here. Okay. Now, if you have the new school calculator, then this is what you're going to see here on your screen. If you have the old school calculator, I'll show you what to do next. If you have the new school calculator, everything here should be just fine. Your X list should be L1, but if you don't have anything there, you hit second and 1 for L1. Your Y list should be defaulted to L2, but in case if nothing's there, second and 2 for L2. You should skip the frequency list. You're going to skip that altogether. You're going to skip whatever this is. You don't care. And then we'll go down to calculate and let it do its thing. For old school calculators, you should see linreg AX plus B at the top of the screen. And then what I would like you to do here, I'm going to go ahead and showcase this out here. Come back to this in a second. This is what you should have for the old school calculator. You should have L1, comma L2. Okay, so second 1, comma key, second 2, and hit enter. This is what you should have here for old school calculators like so, and then hit enter. Alright, I would like everybody to type cool in the chat if we got these exact numbers on the screen. All 4 of them. Type cool in the chat if you have these exact 4 numbers on your calculator. This would be a very good idea to show me. Galley's like, cool. Ooh. I remember that drink. But that was the Q. In Japan, there was a drink called Ku, but it was with a Q and not a C. This reminded me of that. Alright. Now, the reason why I asked you here in this case, like, I normally ask you a lot for the calculator stuff, but the reason why I ask you here in this case is, if we did not turn our diagnostics on here, if we didn't do that one thing before, again, we'd only have to do that once. You would not see the last 2 numbers. So the last 2 numbers you see here, this R squared and R, you would not see those 2 numbers at the bottom. Okay? If we turned the if we left it the same way it was before. So that's why I'm asking here, making sure that we can see those last 2 numbers there. Otherwise, those things will not appear. You'll just see A and B, and then that's it. So, alright. Now, the only thing that we care about at this point is going to be that very last number here, which is R. Our linear correlation coefficient. We will deal with this R squared here, but we'll deal with that at the end of the chapter. Alright. So, R here is 0.8958. Okay, so that's going to be R here, 0.8958. Alright, so now we found our correlation coefficient. Great, that's exactly what we were after here in this particular example. Alright. Now, the next thing we're going to do here is, what we want to do is, once we went ahead and solved for r, we want to go ahead and now establish if there actually is a relationship. Now, if we take a look here, 0.8958 is a pretty close to strong relationship. It's considered a moderate relationship because it's not quite 0.9, but it's pretty darn close. So it's close to strong. It's close to strong, but it's a moderate kind of relationship here between x and y, just by semantics. In any case, though, if there actually is a linear relationship, what we want to look at here is we're going to have to figure that out using this correlation coefficient here. So let's take a good look here. So this is a moderate positive relationship. Now, let's take a look at the steps here to see, does a linear relation exist? So even though, okay, so let me explain this to you guys here. Even though we found an r here, which is a pretty nice number here, that's pretty close to +1. Even though we found a sufficient enough r, the one thing that determines whether or not a linear relation exists besides r is also the sample size. Okay, remember the sample size here can pretty much tell us, like, for example, we've said before in the past, okay, asking 10 people is not going to tell us what the actual, perception or opinion about something is going to be nationwide. All right, we've said that many times before, okay? So we're going to have, like, asking 10 people means absolutely nothing, okay? Asking 1,000 people, on the other hand, is going to tell us a whole lot more, all right? That will be a little bit more reliable. Now, that's the thing that we're trying to actually establish here as well. All right, so what we want to do is we're going to first, let's go through the steps to see if a linear relation really exists. So it says, step 1, find the absolute value of the correlation coefficient r. Okay, so we're going to take the absolute value of 0.8958. The reason why we'll take the absolute value here will be apparent in just a second. So positive and negative values will always turn to be positive. I know this seems a little silly and asinine, but still, just for note's sake, we'll just put that down. So the absolute value of 0.8958 is the same, 0.8958. Easy peasy. Okay, now the next part here, not as clear, but let's take a look at that. Find a critical value that directly associates with the sample size using the online Appendix A, i.e. Table 2, or the table given in the problem on the homework. So there'll be either a table in the problem given on the homework, or you can look at Table 2 here in the book. Let me get the page here, and I'll show it off. It is... Let's warp into the future. It is not that. I'm sad. It is definitely not that. It is different than the other tables that we looked at before, so... Yeah, here it is, okay. That's going to be table... Oh, I think I put the wrong table there. Let me see. I thought it was table 2. Maybe I put the wrong table there. Table 1. Oh, no, that was right. No, that's right. It was table 2. That's page A-2. So let me put that in here. Appendix A, Table 2 on page A-2. Alright, so let me go there for just a second. Show it. Oops. Page is this? Oh, perfect. Okay, page 183. So page A-2 is going to... It's a really small table. It looks just like this. So if you take a look here at the left side of the screen here, again, we have some critical values that are associated with this here. All right, we have n here, and then we have the critical values associated with the correlation coefficient. All right. So in this case here, let's take a look at the critical value based on the sample size. Now, let me ask you a question here, all right? I want you to take a good look here at the right side of the screen here before we write down our critical value. What is the sample size for this data set? What is the sample size for this data set? What is the sample size? Drake says 5. All right. Is it 5 or is it 10? I know you guys got guesses here, so I want to see exactly where we're at. Do you guys think it's 5 or do you think it's 10? Right, Clay says 5. Trimpin says 5. Alright. Issa says 5. Pistache says 5. Alright, good. Good. The answer to this is indeed 5. There are 5 points, okay? Think of it points on the graph here. There are 5 individual points. Alright. So I'll point this out here, Chioma. Instead of thinking about it as individual numbers, I want you to think of it as 5 points on the graph. If you were to put it in a scatter plot has a coordinate of x comma y. So in this case here, and this is the reason why I want to ask this question here, is because this would be the point, say, 2 comma 4. This would be the point 4 comma 8. This would be the point 6 comma 10. 6 comma 13. 7 comma 20. So the actual answer here, again, n is equal to 5 is correct. Okay, so there are 5 points, or again, 5 points in this data set, since we're relating x and y together. If they were separate things, then sure, 10 would be right, but they're not separate because they're associated with each other. That's why. All right, so I wanted to give an explanation about that, because sometimes when I see people do these problems, they sometimes get confused about how many that there actually are. All right. Now, since there are 5 data items in the data set here, we look at the table, and it says the critical value is 878. So, all right. All right, so this is just from the table itself. No problem. Okay, let's go back to page 183. Oh, actually, I don't need to go back. I just need to go here. Let's do that. Okay, now, last part here. Let's go step 3. Step 3 here is if the result of step 1 is bigger than the critical value. If the result of step 1 is bigger than the critical value in step 2, then a linear relation will exist between 2 variables. So we just have to ask the question here, again, just like the hypothesis testing, is 0.878, or not 0.878, is 0.8958, pardon me, excuse me, I'm not being smart, but that's okay, you've known that all semester. Is 0.8958 bigger than 0.878? So yes or no, is 0.8958 bigger than 0.878? Yes or no? Okay, and definitely the answer is yes, okay? Alright, Clay, Chimpin, Chioma, they all say yes, and I happen to agree with all 4 of you. Alright, Jake, Clay, Chimpin, and Chioma, you guys are correct. The answer is definitely yes. So because the answer is yes here, a linear relation will exist between both variables. Okay. Alright, good stuff. If it wasn't, then it wouldn't exist. It's pretty easy. Upperstash says yes, I totally agree. Alright, very good, very good. Okay. Put back this here. Okay. Are. And okay, that's fine. Okay, good. Just had to check something here. All right. Any questions about that? Let me see you bring the Dutch back. Let me see you bring the Dutch back. Let me see you bring it back. Oh. Bring it back. Pretty easy, I hope? Question mark? I don't think it's as bad as it seems. Alright, let's do another example. Oh, that's for the next part. I bet. Okay. Alright, let me go back to the book here. Okay, let's take a good look here at number 25. Alright, we'll quickly do this one. It's not too bad. I'll zoom in on it because I had issues last time. Hello? Oh, there we go. I don't know what happened there. Alright, fine. Okay, so let's take a good look here at 25. Alright. The Gallup organization regularly surveys adult Americans regarding their commute time to work. In addition, they administer a well-being survey according to the Gallup organization. The Gallup Healthways Well-Being Index composite scores comprised of 6 sub-indices: life evaluation, emotional health, physical health, healthy behavior, work environment, and basic access. Alright. A complete description of the index can be found, blah, blah, blah. I don't care. Alright, so, here's the data in the following table that represents your well-being score and in comparison to commute times. So there you have commute times, and there you have this index composite score. Alright. So, let's see, yeah, I guess I would be like, you know, all you need to do is, like, you know, attach a Taco Bell, you know, right next to my place, and I think I'd be fine. I'd have a pretty high well-being score. I think that would be okay. Maybe not. All right. I'll be doing a lecture in class. I'll be like, can I get a cheesy gordita crunch? No tomato. That'd be great. Cheesy gordita crunch, no tomato. All right, let's put this in the calculator. Let's do this again. Let's put it in the calculator, folks. All right, let's hit the stat key. We're gonna hit the stat key. We're gonna go edit. Let's clear out these lists here. Hit clear and hit enter. Hit highlight list, hit clear and enter. And there we go. All right, let's put in these numbers in here. All right, so 5. Okay, so here we have all these lists in here. We have list 2. This is the well-being score. Okay, so these are the numbers that should be in list 1 and list 2. When everybody has those entered in, please type done in the chat. Type done in the chat once you have your numbers entered in, and we will move forward. All right. Alright. Alright, Anna's got it. Good. Alright. Good stuff. Good stuff. Good stuff. Alright. Alright, so next what I would like you guys to do is I'd like you to hit second in mode. We'll quit out to the main screen here once again. We'll go ahead and hit the stat key here. Alright. We're gonna go over to calc, and we'll go down to linreg ax plus b. Again, for the new school calculator, they'll see this list. That's fine. Again, reminder here for the old school calculator people, you'll have linreg ax plus b. Once again, L1, L2, okay, is what you want for the old school calculator. For the new school calculator, just scroll down to calculate, as it should be defaulted to L1, L2. Hit calculate there. Please type "got it" in the chat if you have the same exact numbers that you see here on the screen. Please type "got it" if you see these same 4 exact numbers on your calculator. Okay, good, good. They got it, good. Nice, nice. Alright. Okay. If we got these numbers here, that's good. Let's take a good look here at our results. So obviously, we want to look at what R is. So looking at here for number 25. We have R here is equal to... Oh, well, that wouldn't help, would it? Second. R here is equal to... Let's see if... that, all right, good. That's right below my picture. Negative 0.9805. All right. So there is that. There we go. Okay. Now that we have that, that's perfectly fine. Let's go ahead and see if indeed we do have a linear relationship. So take a look. Step 1, we got to do the absolute value of the correlation coefficient we just found. So we have the absolute value of negative 0.9805. Well, the absolute value of a negative just makes that positive. Okay, so that's fine. Again, everything becomes positive in absolute value land. All right. Even positive things are positive. It's amazing. All right. Step 2, we have to find the critical value here. All right, so we do need the sample size here. Let's go back to our question. All right, so let's go back to our question. What is the sample size according to the problem? What's our sample size here? 7. Yes, 7, absolutely, yes. That is correct. 100%. Everybody says 7. Everybody, I agree. All right. Perfect. All right, so let's find that, again, this next part here, you just have to use the book or whatever table they provide you in the homework. Sometimes they'll have that little blue book thing in the problem. Either way, at least you know where to find it. Let's go to page A2, A-2. We want to look at n is equal to 7 here. We got 0.754, so that's our critical value here. Okay, after that, let's do our last step here. Now we did the tougher part there, just finding it. Now we have to just ask the last step here, do the same kind of comparison that we kind of did last time with, let's basically say is 0.9805. That's our R here. And 805, bro. Bro, why are we doing that? All right. Is 0.9805 bigger than 0.754? Yes or no? Is 0.9805 bigger than 0.754? I would say so. That's pretty... I think that's pretty healthy to say, yeah. I think that's not a problem. Yes, indeed. Alright. So, the question is... Plays like Yee. Yeah, exactly. Yee. Alright, perfect. Every time I think of Yee, I think of Yeezys. And I'm like, you know, those are some shoes I'll never be able to afford. Like, ever. Anyway, I digress. Although I'm not fashionable whatsoever. Alright, so, I have no shoe game, guys. I'm sorry. There's no shoe game here. Alright, so, if the answer is yes, then we can say... the linear correlation linear relation exists. Alright, good. Like, my shoe game is terrible. Like, I think look, I still wear the same pair of shoes that's like 3-4 years old, and I paid like 50-60 bucks for it. And they're like a pair of like I forgot, it was like Reebok or something. So they're really comfortable. They're super comfy. And I didn't even buy... The ironic part is I didn't even buy them here. I bought it in Japan because my old shoes actually crapped the bed when I was walking around. So I bought those shoes, and I'm like... And then I liked them so much that I'm like, I gotta buy another pair. So I had to go look around and see if I could get them delivered. They're like out of... They don't make them anymore, so I was able to find one in my size. I got it for a pretty decent price, so... It was like another like 40 bucks. I was like, ooh, that's pretty good. I ain't gonna complain. So I'll probably take the new pair with me, because this old pair is like starting to be like starting to rip a little bit more. All right, very good, very good. All right. Any questions about section 4.1? That's pretty much section 4.1 in a nutshell. Any questions about section 4.1, ladies and gentlemen? Nope. Nope. None. Nada. Zip. Zilch. Zero. Alright. That's fine. Not a problem at all. We are well on our way to get things going. If we finish up the next section, we may end up doing 2 sections next time. But we'll see. So, we'll see, we'll see. But the goal is, of course, see how fast the next section goes, because it goes pretty fast, so. Okay, very good, very good. Alright. Can you see the whole page? Yeah, sure, of course. The whole page for the first part here, Chioma? Like this? Let me zoom out a bit, hang on. Like, this? Is this okay? Everything. Everything. Sure. Let me zoom out a bit more then. These are the first couple pages there, Chioma. Or the latter half of the... Latter half, I should say. Otherwise, there's some more pages up here. I don't know if that helps or not, but just let me know. I don't know what this side means. This one? I guess? Okay, no problem. You don't have to write down this formula for number 3, by the way. Because we're just going to use the calculator to find it, so that shouldn't be too big of a deal. All right. Done? Okay, no problem. All right, ladies and gentlemen, I want to thank you all for coming on out here today. All of you are absolutely fantastic, as always. Got 3 more sections to go, and we are DONE done. So continue working forward here. We are getting down to the very last throes of this semester. Thank you so much, everybody. I hope you all have an absolutely fantastic evening. Have an absolutely fantastic weekend. As always, everybody, stay safe, stay healthy, but most importantly, stay sane. All right, have yourself a great night. Have yourself a good weekend. Thank you so much, everybody. You guys are great. I love you all. All right, take care of yourselves. Lisa, Pistache Clay, Tori, Chimpin, have a wonderful evening. Have a wonderful day. Have a wonderful weekend. Gally, thank you so much. Anna, thank you so much. Have a good night. Thank you, you too. Hope everybody takes care of themselves. All right, everyone, have a good one. We will see you all later. All right, take care, everybody. Bye. Bye, everybody. See ya.